Hello mathematicians, hope in this video you can say I can analyze tables, graphs, and equations to determine if proportionality. Let's look at one example that is proportional and one example that is non-proportional. We'll compare them side by side. So now we're going to analyze the differences and similarities that these two have and determine how we can decide whether an equation, table, and graph are proportional or not. Let's start by filling in the table over here on the proportional side. So I'm going to plug this column of x values in for x into this equation to give us our y values. So 2 times -4 gives me -8. 2 times -2 gives me -4. 2 times 0 gives me 0. 2 times +2 gives me +4. 2 times +4 gives me 8. So that would be the table here. So now if we were to go ahead and graph this table right here, well, we'd find -4, -8, which would be this point right here. And now we graph the point -2, -4, so 1.00 is right in the middle, and that's an important one to remember when we're determining if it's going to be proportional or not. We'll talk about that later. And I'll find the 0.24. So this is our table filled in, and this is be our graph of this equation y equals 2x. Now let's move on over to the non-proportional side, and we'll fill in our table and then graph it, and then we'll talk about what makes this proportional as opposed to this non-proportional. So if we were to plug -4 in for x, we get 2 times the -4, which is -8, plus 1. So -8 plus 1 would give us -7. Plug -2 in, 2 times -2, which is -4, plus 1 is -3. Plug 0 and you get 2 times 0, which is 0, plus 1, which is 1. So now this has a 0.01 it. That is important to remember. And I would plug 2 in. 2 times 2 is 4, plus 1 gives us 5. And we plug 4 in and get 2 times 4, which is 8, plus 1, and we get 9. So this would be the table filled out here now. So I'm going to go ahead and plot these points and graph it. Now here is our line representing the equation y equals 2x plus 1. Let's start by talking about the graphs of these two equations. What makes this graph proportional is that it is a straight line, it is linear, and it goes through the point 0, 0. It goes through the origin. This graph over here, it is a straight line, it is linear, however, it does not go through the point 0, 0. That makes it non-proportional. So in order for a graph to be proportional, it needs to go through the origin, or the point 0, 0. Now a way to determine that this is a proportional table, say we were not given this graph here, and we were just trying to determine straight off of this table right here, is again, our constant of proportionality is determined by taking k equals y over x. Say we had a third column in on this table right here, which is our y over x, or our constant of proportionality. Well, we would get, over here, we'd get -8 over -4, which is equal to 2. And then on this row right here, we get -4 over -2. And we'd get equal to 2. And you cannot do it when it is 0, 0, so we're just going to leave that one blank for now. And now we're going to move down over here, and we're going to get 4 over 2, which is equal to 2, and 8 over 4, which is equal to 2. So all of our y over x's are the same. They're all equal to 2. Our constant of proportionality is 2 in this equation, or in this table right here. Now, if we were to do the same over here in this non-proportional table, if we were to take our y over our x, we would get, well, we get -7 over -4, which, well, when simplified is just +7 over 4. And now if we move down to this next row, we get -3 over -2, which is just +3 over 2. And we know that 7 over 4 is not equal to 3 over 2. These are not consistent. Your y over x's are not all the same. If we're to continue this process, we get 5 over 2. Well, that's just equal to 5 over 2. And it's clear to see 5 over 2 is not equal to 3 over 2. Or if we continue again, we get 9 over 4. Well, we can't simplify that. So all these fractions are not the same. There is no constant of proportionality. Okay, so that makes this table non-proportional because the y over x values are not the same. And all that it takes is one set of y over x values in this table for it to be non-proportional. proportional. Now let's talk about just the equations themselves. Well, we see the proportional is just y equals 2x. Or the y equals kx, right? That represents a proportional relationship. So y equals 2x. And this is y equals 2x plus 1. It has the plus 1 at the end. So what makes this proportional is that it does not have the plus 1. The non-proportional one has a plus 1. And you will see in your more advanced math careers that this is known as our y-intercept, but we're not going to get into that right now. So just to wrap things up, in order for an equation to be proportional, it cannot have a plus anything after we get our constant proportionality and our x. So y equals kx represents a proportional relationship. For tables, our y over x values are the same no matter what we're talking about, excluding 0, 0. You cannot divide by 0, so that whenever you have an x value 0, you do not include that. And non-proportional, well, it has y over x values that are not consistent with each other. And if we're looking at an equation, it is a linear line. It's a straight line that goes through the point 0, 0, whereas a non-proportional graph needs to be, it is a straight line in this instance, but it does not go through the point 0, 0. So what makes it non-proportional is either it is not a straight line or it does not go through the point 0, 0. So that is it for a video. Hope after watching this and getting in a little bit of practice, you can say, I can analyze tables, graphs, and equations to determine if proportionality exists.